Hello everyone, you're welcome to another class with Mr. Olukorede. I want to believe you guys are doing fine. Okay, so we are going to continue from where we stopped in the last class. I want to use this opportunity to welcome those people that are just joining this class for the first time. You are especially welcome, right? Okay, so what we do here, we do mathematics, we solve problems. So if you have any problem in mathematics you want us to attend to based on the topic we are doing, please you can bring it to the class and we are going to do justice to it. All right, okay, so now for the new viewers, please before you leave, don't forget to click on the subscription button, and if you actually love the class, make sure you tap on the like button. So every one of you should do that. Okay, so as you are joining the class, ensure you say hi to everyone, and don't forget to tap the like button. All right, and don't forget, invite your friends, let them know the class have started. Okay, so and just like you are quite familiar with that, this class is always interactive, so every one of you should have your writing material. So you should get your calculator or your four-figure table close to you, your notebook, and your pen. All right, okay, so let's get that ready. In the next few seconds we are going to commence the class. Thank you. All right, good evening to you. You're welcome to class. I'm Ajayi Amida. You're welcome to class. Okay, who else is in the class? Once you join the class, just say hi. Let us know those that are in the class before we commence the class. All right, okay. Yes, as you are joining, make sure you say hi, greet everyone, and tap the like button. If you are new, you have not subscribed, ensure you do that. Now let's swing into action. Let's solve the first problem we have here. AB is a chord of a circle center O if length AB is 24.2 centimeter and the perimeter of the triangle AOP is 52.2 centimeter. We have to calculate the shaded region correct to the nearest centimeter. Now this question is a WAEC question. It was asked in 2004. Okay, so now let's see how we are expected to solve this problem. Okay, so now when you look at the question, now we are given the length of chord AB, to be 24.2 centimeter. What else are we given? We are also given the perimeter of triangle AOB, right? So what is the perimeter? Perimeter of triangle AOB is 52.2 centimeter. Okay, so that is what we have. So now I want to calculate the shaded region, that is the segment. Now, so there are things that are needed to calculate this. We need the angle subtended at the center of the circle. We also need the radius, which is not given in the question. So we should find a way of getting the radius and the angle. All right, so now let's start with this second thing given here, perimeter of the triangle. So perimeter of the triangle is given. So that is, if you add this side plus this side plus this side together, when you add the three sides together, it will give you 52.2. So that is what the question is saying. So now we have R plus length AB. Okay, this length AB, okay, equals to 52 centimeter. All right, and AB has been given, which is the chord of the circle. Okay, so we have 2R plus 24.2 equals to 52.2. Okay, so now what do? We subtract 24.2 from both sides. We have 2r equals to 52.2 minus 24.2. Okay, so we have 2. Now 2 minus 2, that is 0. Okay, 12 minus 4, that is 8. Okay, we have 4 left. 4 minus 2, we have 2. So we have 28. Alright, so here you can divide both sides by 2. So you divide both sides by 2, you have r equals to 28 over 2. So therefore, r equals to 14 centimeter. Okay, so now the radius here is 14 centimeter. Now, what else do we need to know? We need to know this angle here. Alright? Now, how do we get that? Okay, now let's see what to do. Okay. All right. Now let's continue. So now, let's get her theta. Sorry, I want to get theta. Okay. Just give me a minute now. Okay, so we want to get the theta here. So how do we get theta? Now we are going to make use of length of the chord. The length of the chord has been given. So what's the formula for length of the chord? We have AB equals to 2r sine theta. Okay, this is the formula for over 2. Sorry, this is the formula for finding length of a chord. All right, so the length of the chord has been given to be 24.2. Now 2 times r. What is r? We have gotten that is 14 sine theta over 2. Okay, so now when you multiply this together, you have 28. So we have 24.2 equals to 28 sine theta over 2. Okay, so divide both sides by 28. So you have 24.2 over 28 equals to sine theta over 2. Okay, I hope you get that. All right, so now what do we do next? Now, what is going to be the decimal of this? Now, can you compute that now and drop the answer in the comment section? What is 24.2 divided by 28? Okay, can you quickly compute that and drop the answer in the comment section? I said it earlier now that today's class is going to be interactive, so don't let me be the only person that will be solving here. Okay, so now do that and drop your answer in the comment section. What do you have for that? 24.2 over 28. So is anybody dropping the answer here? Anyone? Okay, am I seeing someone dropping? Okay, all right. Okay, Toyosi, I can see that 0.864. 0.864. Yes, that's correct. That's 0.864. All right, equals to arc sine of theta over 2. Okay, a sine of theta over 2. So you take arc sine of both sides. Okay, all right, so let's take arc sine of this. So we have arc sine of 0.864. Okay, now we have theta over 2. So when you take arc sine of this side, so this sine go. So now you multiply 2, each of the figure we have here. So the terms, sorry, you multiply this by 2 and this by 2. So you have 2 arc sine of 0.864, and you have answer of theta. So now let's find this. What is arcsine of 0.6864? Yes, can you compute that now? So you press shift, sign, and you press the number. So you tell me the answer. So you drop the answer in the comment section. Okay. So arcsine of our results. So what do you have? What do you have when you find the arcsine? Please kindly drop your answer in the comment section. Yes. All right. What do you have? Arcsine. So because of our time, if you compute it well, you're supposed to have 59.80. Okay, so therefore theta equals, so when you multiply that by 2, you have 119.6 degree. So this is what you have for the angle. Okay, all right, so now we have gotten the angle. All right, so the angle subtended here, the angle here is 119.6 degree. So that is what we have. So now the next thing here is to find the shaded region, that is the segment. So I hope you remember the formula for calculating segment of a circle. Now segment, okay, the segment, area of segment is area of circle, area of a sector, sorry, that's theta over 360 pi r squared minus area of the triangle. Okay, that's 1 over 2 r squared sine theta. Okay, so that's the formula for finding area of a segment. Okay, so now can we input all these parameters and see what we're going to have? So this is going to give us 119.6 over 360 times 22 over 7 times 14, okay, 14 square. Let's say 14 times 14. All right, let's use 14 square so we can still factor that out. Minus 1 over 2, 14 square sine 119.6. Okay, so here let's factor out 14 square. So we have 14 square here. So what we are left with is 119.6 over 360 times 22 over 7. Okay, minus 1 over 2 sine 119.6. So what do you have when you find sine of that value? So let's find sine of that sine of 119.6. So what do you have when you do that? So sine 119.6. So you have 0.8. So this will be times 0.8695. Okay, so that's what we have. All right. So now this will give you 196. Now let's evaluate what we have here. Okay. So we have 119.6 times 22. Okay. Everything divided by 360 times 7. Okay. All right. So what do we have for that? We have 1.0441. So minus. Now let's look at this. So we have 0.8695 divided by 2. So what do we have? we have 0.43475. Okay, so 19.6 times 22. Okay. Okay, now, so we can now subtract. So we have 196 times. Now, what do we have when we subtract now? So when you subtract 1.0441 from, you take this from 1.0441. Okay, so what do you have? So I hope you are doing that over there. So make sure you cross check. Okay, 43475. Okay, so now here I have 0.66093 before. So we can multiply that by 196. Okay, so to do that, you have 119.43, and that is going to be in centimeter square, because we're actually looking for the area of the segment. Okay, so now you can correct that to the nearest centimeter according to the question. So that means to the nearest whole number. So we have 119 centimeters square, nearest centimeter. Okay. That's the nearest centimeter square. Okay, so that is what we have for that question. All right, so before we move down to the next thing, any observation, any question based on what we have done? Right, so I want you to drop your thoughts in the comment section before we commence. Yes, any observation, any question based on what we have done? So if you have any question based on what we have done, please drop that in the comment section. And don't forget, as you are joining the class, make sure you tap the like button. If you are new on this channel, don't forget to subscribe to this channel. All right. Okay, so now let's look at another question. This is another WAEC question which I want you to pay attention to. In the figure, OQRS is a quadrant. The quadrant of a circle, center group. OXRT is a rectangle by 12 centimeters. So calculate the radius of the circle. So area All right, so that is the question. That is the question to the problem. So yes, can I give you 2 minutes to quickly attend to this question? Can you make an attempt? Now, how do you solve this problem? Now, in the figure, OQRS is a quadrant of a circle, center O. OXRT is a rectangle, 16 centimeter by 12 centimeter. Calculate the radius of the circle and the area of the shaded portion to the nearest three significant figure. Now, can you try this within 2 minutes? Let's see what you are going to have. Just make an attempt. Okay, so make sure you are doing something. Okay, so even if you didn't end up getting the answer, just make an attempt. Just do something. Make an attempt and let's see what you're going to have. So by the time we start solving it together, you can just oppose it with what you have with you. Okay, once you have your answer, you can drop it in the comment section. If you have done the first part of the question, okay, you can make an attempt and try the first part, the radius of the circle. Let's see what you can come up with. Okay, Shomide, you are welcome to class. Divine, Riscott, okay, Mahmoud, all right, it's been a while, Mahmoud. Okay, so all right, so let's see what you are going to have. Yes, so I'll be waiting for your results. Yes, Toyosi, yes, can you drop your answer? I hope you are making an attempt. Hope you are trying it. Okay. Anybody? Oh, okay, you are still struggling with it. Okay, I can see Toyosi saying yes. You are still struggling with it. Okay, let's see. Yes, just keep thinking. Keep thinking. Okay. Okay. James Mohammed is asking which formula is used because it looks like a square. All right. We are using the same formula. Look at it. Since it's a square, now think of what to use. Now we have discussed about quadrant of a circle. All right, you know what a quadrant of a circle means. All right, so and you know what the radius is. You know what a radius is. It's the shortest distance between the center of the circle and the circumference. Okay, so yes, those are the hints you have, and then you can look at the triangle. Look at that rectangle carefully. The solution lies in that rectangle there. Look at it carefully. That's where you get your answer. Okay, let me just give you like 30 seconds more because of our time so that we solve it together. Okay. Okay. Pi is used. Radius is half a diameter. Okay. You are correct. Radius is half a diameter, yes. So now use it in context and see how we are going to apply that. Let's see. Is there anything you can do to that rectangle So you have to do something to that rectangle. That is where the solution lies. So I want every one of you to examine that rectangle. What can you bring out of it? Okay, area of a rectangle first. Oh no. All right. Okay. So now let's solve the problem together. Yes, I can see James trying. All right. So you see, the best way to know mathematics is just begin to rack your brain. You rack your brain and look for several ways of getting it. Even if you miss it, it's just a process of getting it. All right. So now let's look at it. Now I need to get the radius. Now look at it. OS is the radius because this is the center of the circle. This is a quadrant. I told you what a quadrant is. Now when you divide a circle into 4 parts, we have the first, the second, the third, and the fourth. Okay. So and a quadrant is from 0 to 90. So the angle in a quadrant is 90 degrees. So it's 1/4 of the whole circle. A quadrant is 1/4 of the whole circle. All right. So if you know that, that means that you already know the angle we have here. So there are several things that is even pointing out the angle, that this is also 90. But that is not what we even need now. So what I'm going to do now is just to draw a construction line here, because I want to get the radius. OS is the radius, OQ is the radius, OR is also the radius. All right, so now this is the one I'm going to use now. So I'll just bring out this triangle. I'll say in triangle ROT. Look at this triangle ROT. The dimension of the rectangle has been given. All right, we have 16 by 12. Okay, we have 16 by 12. So now you just get this R here. Do you understand now? So we have R square equals to the square of the opposite square sides. Okay, now we have 12 square plus 16 square. So when you add the squares of the opposite side or the two sides together, that gives you the square of the hypotenuse. All right, so we have R square equals to what? That's 144 plus 256. All right, so now let's add together. When you add together, you have what? 3 what? That is 400. Okay, so we have 400. So then you can find square root of both sides. So we have square root of 400 is what? Is 20 centimeter. Okay, so that is 20 centimeter. That means the radius is 20 centimeter. I hope you understand that now. So that is how to get the radius. Yes, any observation, any question? Okay, about what we just did now. All right, so James Mohammed, so what do you now see to that? Can you see it's now easy to work out? Okay. All right. Adewusi, you are welcome to class. Oh. All right. Okay, good. So now, that is how to get the radius. So now let me come again because of the person that said no. Now look at it. The radius is the shortest distance between the center of the circle and any part of the circumference. This is fraction of circumference of the circle. So from here to here is the radius. So now this line now divide this circle this rectangle into two parts. So I brought out a fraction. Now it looks like this. Okay, you know this is right angle now. So we have 16 and we have, don't forget this is radius. Okay, so and use Pythagoras theorem to get the radius. Okay, so that is what we just did here. So that's how we got the radius. So radius R is 20 centimeter. Okay, so now the next question now is to get the shaded region. To get the shaded region. Should I give you a minute now to do that now? So to get the shaded region is very simple. Okay, so I just need someone to tell me what will I do to get the shaded region. Now look at it, examine the diagram very well. So what are you going to do to get the shaded region? This area and this area. You don't need to work it out. So we are going to work it together. Okay, we'll get the answer together. So what are you going to do to get this shaded region? So if you know, drop it in the comment section. So look at the diagram carefully and think on what to do to get the shaded region. It's very easy. So anybody? Anybody? Okay. Okay, James. Okay, just follow the video. Probably maybe after the class you can go through the video again. All right. Okay, you are trying, making a good attempt. That's a very good one. But just let's follow what we are doing here. So is there anyone that can tell me how to get the shaded region? So I need you to think now and tell me what to do. So just tell me what to do, what we are going to do to get the shaded region, and we'll go ahead, we solve. Anybody? Okay, Adewusi, I want you to say something. All right. Riscott. Yes, say something. Show me the, yes, I can see you guys. All right. So what are we going to do? So examine, critically look at the diagram and see, how do you think we can get that shaded region? I need someone to tell me what to do. You just need just a step. So that step, once we take the step, we're on our way to the answer. Yes, anybody? Okay, James said 20 minus 12 is x. 20 minus 12. Okay, what are you talking about? Is that what you want to do? No. Okay. Okay, is it equals to x cubed? No. We are looking for area of the shaded portion. Area of the shaded portion. So that's what we are looking for. Okay, no problem. I'm going to tell you, since nobody is able to give me the answer, so I don't think it's so difficult. Now let's look at it together. So now, looking at the figure, we have disregard what we have inside. What do we have there? We have a sector. This is a sector. Or we say a quarter of a circle. Quarter of a circle, that's what we have. So out of that quarter of a circle, just take away this area, this rectangle. Once you take away this rectangle, what's left is the shaded region. That's all. That's all. I hope you understand that. Out of everything we have here, I want the shaded region. Just take away this from everything. Once you take away this rectangle from there, what will be left is the shaded region, and we are good to go. All right. So I will now write now shaded region equals to area of rectangle, or let's say area of not area of rectangle first, area of sector minus area of rectangle. You understand that? Out of this sector, take away this rectangle, so we are left with the shaded region. So now, so how do we do that now? Area of sector. So I don't need to begin to rack my brain on the formula for calculating area of the sector. Since this one is 1/4 of the whole circle, so I can just write 1/4 pi r squared. You understand now? Is all the area. So you take away area of rectangle, that's length times breadth. So this is the formula we are using. Okay, so now we now have 1/4 times 22. Okay, this time around we are given 3.142. So you must not use 22/7. If you use 22/7, so you are going to miss a mark here for wrong substitution, because the question asks you to substitute 3.147 to be your pi. So now we have 3.142, sorry, that is your pi, times, what is r? The radius. We have gotten the radius. What do we call the radius? That is 20 square minus length times breadth. What is our length? Our length is 16, while the breadth is 12. Okay, so how do we evaluate this now? Okay, so we have 400/4 times 3.142, okay, minus, now let's multiply this. 2 times 6 is 12, 2 times 1, 2, that's 3, 6, 1. So we have 291. So minus 192. Okay. All right. So now let's move down to the next thing. Now 4 goes here 1, 4 goes here 100. Okay. So we can now multiply that 100 by this. So that's going to give us 314.2 minus 102. So, okay, can we subtract that? Now let's subtract that, and we'll get our answer. 304.2 minus 192. So what do we have? We have 122.2 centimeter square. So this is going to be the area of the shaded portion. The area of the shaded portion. The area of the sector minus area of the rectangle. That gives us the area of the shaded portion. Yes, that is the answer to the problem. Any observation, any question? All right. Based on what we have done now. Any question, any observation? Okay. All right, if there's no question, now can we move down to another interesting question? This is another one. Okay, so now can we look at this next question? So we want you to try this before we do it together. It's just a replica of what we just did now. So now the diagram shows a rectangle PQRS inscribed in a circle. Length PQ is 6 centimeter and QR is 8 centimeters. Okay, this is 8 centimeter. Okay, QR is 8 centimeter. All right, so you have to calculate correct to three significant figures the total area of the shaded part. Right, so now with what we just read now, can anyone tell me what is the method we're going to use to get the shaded region? Right, so how do we get the shaded region? Yes, if you know, drop that in the comment section. How do we solve that? What approach are we going to use to solve that, to get the shaded region? Now once you're able to tell me, then we can now go ahead and find the shaded region. Okay, Divine, tell us how are you going to get the shaded region? How do we go about it? Is anyone telling us what to do? What are we going to do? Examine the diagram very well. So how are you going to get the shaded region? Let me know your view on it. Okay, anybody? All right, so yes, it's straightforward. Now this one is straightforward. If I want to get this shaded region, I'll just find out of the total area of the circle, I will remove this rectangle from it. So once I remove this area of rectangle, what I'll be left with is the shaded region. That's all. So now, shaded portion, the shaded parts equals to area of the circle, that's pi r squared, minus area of the rectangle, that's L times B, length times breadth. Okay, so and that gives you 22/7 times the radius. Now you can see that we have an issue now. We need to get the radius. So how do we get the radius? Now this is the center of the circle. So we can draw a line such that it's going to go through this way. Okay, so now we have this right angle. All right, so since this is 8 and this one is 6, so we can get this, which is the diameter. Right, so now let's do that. So that means we have to do that before this. Okay, so now let's get the diameter. All right, so now you look at triangle QRS. Look at triangle QRS. This is the triangle. It's a right angle triangle. So we are going to be making use of Pythagoras theorem to get this. All right, so we have d squared equals to the squares of the remaining two sides. So that is 16 squared plus 6 squared. So we have d squared equals to 64 plus 36. And d squared equals to 100. Okay, so and d is square root of 100, which is what, 10 centimeter. So the diameter is 10 centimeters. So we can get the radius. So what is radius? Radius is half of diameter. So R is D over 2. That is 10 over 2. And that's what? 5 centimeters. So that is the radius. Okay? I hope you understand that. So we can go ahead now and find the shaded parts. So shaded parts. The shaded parts is pi r squared minus length times breadth. Okay, area of the circle minus area of the rectangle. Okay, so and that gives us what? 22 over 7 times r is what? 5 square minus length times breadth. What is the length? Length is 16, is what? 8, and the breadth is what? 6. Can you see that? So now you have 22 times 25 over 7 minus 48. Okay, so now can we evaluate this? We have 22 times 25 divided by 7. So what do we have? We have 78.57 minus 48. So when we subtract it from 48, what do we have? We have 30.57 centimeter square. Okay, so 30.57 centimeter square. So this is the area of the shaded region. But don't forget that the question says correct your answer to 3 significant figures. So what is going to be the answer? Final answer now, 3 significant figures. So the first significant digit here is 3. Just count 3. 1, 2, 3. So this is what you are writing out. So but look at the next one. Is it up to 5? Is up to 5. So you increase the last count by 1. So you have 30.6. And you throw the remaining ones away because the digit is after the decimal point. So you throw the digit away. So that means the answer is 30.6 centimeter square. So this is the area of the shaded region. Okay. Yes, I want to believe we all understand that explanation. All right. Okay, so can we just hang it here for today? Let's hang it. I have a lot of questions here, but there's no how we can exhaust everything. Okay, so in the next class, we are going to be moving down to the second session of mensuration, which is the solid shape. Okay, we look at the solid shape. So that is what we are going to be looking tomorrow. So make sure that you are available for tomorrow's class. All right, because the foundation really matters. Because what we are going to be looking at, we look at the formulas. We look at formulas of common solid shape. So after that, we now begin to treat questions under solid shape. So I want to believe you are not going to miss the class. Don't forget to invite somebody, inform someone in your neighborhood that is a student, okay, to be part of this class. All right. So thank you very much for those of you that started with the class down to now. Right. Thank you very much. And those of you that are just joining this class for the first time, I really salute you. You are welcome to class. And those of you that just subscribed, I also appreciate you. Thank you very much. Make sure that once you are notified, you join the class immediately. And don't forget, this class is always interactive. Anytime we're in the class, make sure you have your pen, your calculator, and your book with you. Okay? So thank you very much. Bye-bye.